Hi, everyone, and welcome to today's Germination Retail Roundtable webinar. My name is Mark Zinkowitz, and I serve as editor for Germination, and today I'm happy to be your host. Today's theme is Spore Wars, the battle against airborne plant pathogens. Before we begin, I would just like to thank our sponsor, 2020 Seed Labs, for its support. We'll be doing some live tweeting during the proceedings, so I encourage you to engage with us on Twitter by following the hashtag #SeedRetail as we go along. If you're not already aware, a pesticide applicator credit applies to anyone in Alberta who views the webinar and has a pesticide applicator license. Just go to germination.ca/applicator-form. You can email your completed form to Kevin Zaechuk at kevin@2020seedlabs.ca. Also, during the presentation, you might have a question for one of our speakers. Please type these into the chat box at any time during the webinar, and we'll address them during the Q&A sessions that we'll hold after each speaker finishes their presentation. Also, today's webinar is being recorded, and it will be made available at germination.ca following the proceedings. I'd like to begin the first of our three presentations today. Kelly Turkington is a plant pathologist for Agriculture and Agri-Food Canada. His main focus is on barley, wheat, and canola disease. He's currently involved with research related to the development and use of plant resistance for disease control in cereals. He's studying the impact of cropping systems on disease development, fine-tuning the use of fungicide application for disease management, plant disease surveillance and risk assessment, and the development of practical integrated solutions for crop health and disease management. Kelly, the floor is yours.
Awesome. Thank you so much, Mark. It's an interesting theme, Spore Wars. I'm not sure which character I am. Some days I feel like Jabba the Hutt, but what I'd like to do is to give you a sort of a quick overview of the potential of using spore trapping for assessing the risk of Sclerotinia stem rot. So we'll talk a bit about the disease itself and some of the past approaches to risk assessment for Sclerotinia, and then finish off with sort of an overview of how we might go about using spore trapping to assess the risk. Before I start, I always like to acknowledge the colleagues that I work with. And unfortunately, last week, my graduate student supervisor, Robin Morrell, passed away. So I've been reminiscing a bit about my past and some of the key mentors that you can see there. Certainly, Robin Morrell, my father, a good friend of my father's, Bobby Folden, and over the years, a number of key extension staff, crop consultants, and advisors and industry reps. Of course, the funding for a lot of our work is provided by producer groups. And finally, I'd like to thank Kevin and the team at 2020 Seed Labs with the opportunity to present to you today. So if we look at Sclerotinia, it's a disease that has the potential for substantial losses. It's quite variable in occurrence between crops within a region, between regions themselves, and certainly between years. The disease itself and the pathogen that causes it, Sclerotinia sclerotiorum, has quite an extensive host range, and that includes most of the common broadleaf weeds and crops that we encounter in Western Canada. In general, the success of sort of traditional cultural methods of control has been limited. So things like rotation and tillage and so on, and that really is the result of the longevity of the fungus and the sclerotial bodies that it produces that allow it to survive between growing seasons, its wide distribution in terms of host crops that it can affect, and the dispersal potential of the pathogen. So the spores that it produces can certainly move from one field to another. Because of that, because of the limited success of cultural control measures, fungicides are a key strategy in terms of managing this disease. Now, one thing that we always want to look at with any plant disease and developing strategies to manage it is to have a good understanding of the disease itself and how it operates. So the fungus survives in the soil of Sclerotia, and typically in mid-June, once the crop canopy starts to cover the soil surface, you get moisture so that the soil is close to or at field capacity. And that crop could be a canola crop, it could be a field pea crop or a wheat crop. It really doesn't matter as long as the sclerotia are present in the soil. So those sclerotia will germinate to produce the fruiting structure of the fungus, or the apothecium. You can see that here in the picture, and it's where all the action occurs. So if you looked at this under a microscope, you'd see these sacs of spores that are being produced, and those spores are actually literally shot up into the air like small cannonballs, and those spores then are caught by wind currents, and those are carried to the canola inflorescence during flowering. The spores land on the petals, and those petals are key in terms of the disease cycle of the Sclerotinia stem rot fungus. The spores themselves, if they land directly on the leaf tissue or leaf base, they don't have enough nutrient reserves in order to directly infect the plant. So the spores actually germinate or land on the petals. They start to germinate in the petals, and that can occur while those petals are still up in the inflorescence if you have moisture. But more typically what happens is those petals carrying the spores of the Sclerotinia fungus will actually fall off. Normally they senesce and fall off, and they'll clump down in the crop canopy. And you can see at the base of this leaf quite a large clump of petals, and at the same time you see a nice droplet of water, which provides a good environment for the fungus to grow in that petal tissue and then down into the plant itself. And that ultimately results in disease in the crop canopy. And for Sclerotinia, the key infections are really on the main stems or the main stem branches. If you get infections up in the upper canopy on pods and some of the flowering parts of the plant, the impact on yield is typically fairly minor. Now, the problem with controlling Sclerotinia is you actually have to spray before you see symptoms. So you have to make that call, you have to do your risk assessment prior to the appearance of symptoms. So that makes it quite difficult to assess the risk of Sclerotinia. In contrast, if you look at cereal leaf disease development, when you're out scouting for weeds, you can note the development of things like scald in barley, which is in this picture here, or net blotch, or tan spot in wheat, or septoria, and you can identify a developing problem, especially as that crop transitions into stem elongation, flag leaf emergence, and into head emergence. And you can actually see the disease and use that as an indicator of risk, especially the disease developing in the lower and the middle canopy. You can't do that with Sclerotinia. So what over the years has been done is that researchers and extension staff have developed various sort of guidelines to assessing the risk of Sclerotinia, and those include things like the well-known Sclerotinia checklist, Sclerotinia weather-based risk maps, and there's an example of that from the late 90s from Manitoba and parts of Saskatchewan. Those have come and gone depending on the province and year. Some individuals advocate the use of sclerotial depots, so you bury the sclerotia in a known location in a field, and then you monitor the appearance of apothecia. As a student in Saskatchewan back in the mid-80s, I worked on the idea of testing petals, and it was sort of a surrogate or an indirect way of spore trapping, and I'll talk a bit more about that in a few moments. So if we look at assessing the risk of Sclerotinia, one of the important things that we need to do is to look at the pathogen itself, because it's a monocyclic disease. The amount of disease at the end of the season is directly proportional to the amount of inoculum floating around in the air in July. You can also try to crawl around in your hands and knees and look for apothecia. Not a pleasant thing to do, and I'm in the middle there. You can see who's doing most of the work, by the way. Given issues with clubroot now and concerns regarding spreading soil from one field to another, even on people that are walking into and out of fields, I look at that rain suit that I'm wearing, and it would be cause for concern as far as spreading, potentially spreading clubroot. What we did, though, is we looked at assessing the pathogen itself, and we didn't spore trap because simply it was difficult to assess the pathogen using spore trap samples. What we did is we used an indirect approach. We looked at collecting petals from the flowering plants within that crop canopy, plating them on agar plates, and letting the fungus grow out, and then assessing the number or percentage of petals that were infested. And the petals are a key part, as I mentioned previously, of the disease cycle. So we could look at relating the percent infected plants to the percentage of petal infestation at flowering, and it was certainly a useful strategy to implement. The challenge, though, with it, and you can see me on the right-hand side of the screen when I was a lot skinnier and I had a bit more hair, assessing plates for Sclerotinia, and usually that was about 3 to 5 to 7 days after plating. So it meant the results were available a little later than we would normally like. Now, if we look at spore trapping, one of the things that we need to understand is the role that spores play and how they operate, the biology of spores and so on. And I'm not going to go into a lot of detail here. There's a lot of background information that we could cover, but one of the key things is how these spores are dispersed. And so they're released from the fruiting structures in the case of Sclerotinia. They're shot up into the air. They're carried by wind currents. So the spores are the key mechanism of the wind is the key mechanism of dispersing those spores. So those wind currents carry the spores. And if you look at the scientific literature, ascospores of Sclerotinia typically can be dispersed anywhere from 1 to 500 meters. Other examples of aerial dispersed or wind dispersed spores include Canidia of the net blotch fungus or the tan spot fungus, and certainly ascospores of Sclerotinia, blackleg, and fusarium. Now, these spores are typically not adapted to survive more than a few hours or a day or two. They're susceptible to wetting and drying, they're susceptible to UV radiation, and they're typically, depending on the pathogen, thin-walled and colorless, which again make them fairly fragile and not very long-lived. In contrast, other fungi and other pathogens, especially the rust pathogens and cereals, produce spores that can be dispersed over long distances, so anywhere from tens of kilometers to thousands of kilometers. So if you think of stripe rust, traditionally the main source of stripe rust is coming from Washington State, Oregon, and northwestern Idaho. Those spores are adapted to that long-distance trip and can survive for several days or even longer because they're resistant to wetting and drying, they're resistant to UV radiation, they're thick-walled and pigmented, and can survive that trip. So a lot of the rust fungi are adapted for very long-distance dispersal. Now, if we look at assessing spore loads in the air, traditionally spore trapping and the use of that approach and that technology was really confined to the research realm. It wasn't something that would be used typically on farm by a farmer or a crop consultant or so on. And usually the spore trapping studies were used to investigate spore biology, epidemiology, and just the nature of spore dispersal and so on. And spore traps can be basically very simple passive impaction methods. So you can trap spores via a sticky surface or a filter membrane when it's exposed to the air. So good examples of that include microscope slides that you've coated with Vaseline or some sort of sticky substance, or these long rods that may spores may impact on, or the Spornado, which Trevor will be talking about in a few moments. It's a non-quantitative way of assessing spore load in the air. So you can't assess the number of spores per unit volume of air per unit of time. You can also use petri dishes that have growth media in them, and they can be set out in the field, and spores can either settle onto the plates, or if you have them on the side, the spores can actually be blown onto that agar surface. But again, it's non-quantitative. We can also have active impaction methods, and typically what those involve is a vacuum source that pulls air into a trap. The spores are then impacted on either sticky tape or other types of coated surfaces or petri dishes or even filter membranes. And it's typically used again for quantitative assessment of dry wind dispersed spores. So the number of spores per volume of air per unit of time. The other type of trap that has been used traditionally is the rotorod sampler. And basically it's a bar that has coated rods that spins at a very high RPM, and the spores are actually impacted on those rods, and you can calculate the number of spores per volume of air per unit of time. Just some very quick examples of some of the active volumetric traps for spore trapping. These things tend to be more of a research-focused piece of equipment. They're quite expensive, and in many cases they require a fair bit of maintenance. We're using at Lacombe the rotorod sampler, and I just mentioned that previously. So to stay on time, we'll move ahead, but it's just an example of the rotorod we had deployed this past summer in Lacombe. Now, what about assessing the spore load? Well, the traditional methods include direct microscopic examination of the slides or the trapping surfaces. Or we might actually wash off the spores off those trapping surfaces and then look at them under the microscope. If you look at culturing of spores on growth media, the spores germinate on the media, and then we identify them based on their colony morphology. If we've washed them off, you can take that and put it onto a separate growth medium and again identify those fungal colonies that result. The problem is that these approaches are fairly cumbersome and time-consuming. Works well for a research environment, not so much for a commercial field. The spores themselves need to be distinct to facilitate identification if you're looking at them directly, or the cultures that you grow out actually in some cases may need to be subsampled to have a closer examination of the spores and other structures to identify what fungus you're dealing with. Now, over the last 10 years, we're seeing the dawn of a new era, and many of you probably have heard of molecular approaches to pathogen detection and detection of other things. And this is using things like qPCR and other methodologies. It can be very rapid and accurate. Now, if we look at using molecular approaches, typically they've been used more in a research realm, but how do we take that technology and marry it with spore trapping and move it beyond the research realm? Well, this can be facilitated by the use of inexpensive, simple to use, and robust spore traps that require limited maintenance, timely testing services at reasonable prices, and finally, and last but not least, a better understanding of how results relate to risk. And I'm going to talk just very briefly, we're almost done here, in terms of assessing the risk of Sclerotinia and how a farmer or a crop consultant may do that. Now, in this particular presentation, we don't have the animations available, but if you look at the bottom part of the slide, there are host-related factors: growth stage, yield potential, the variety you're growing to a certain extent, and the commodity price. So that's host part of the equation. The next thing is you can look traditionally at things like disease history in your field or adjacent fields, or the presence of apothecia, or perhaps if you're so inclined, you can look at testing petals. But again, one of the alternative approaches to that is to use modern molecular techniques and marry that with spore trapping to determine the DNA load, so the nanograms of Sclerotinia DNA per unit volume of air or per unit of time if it's available. The next aspect is you need to look at the weather conditions, both ambient and in-crop environmental conditions, especially in terms of relative humidity and temperature. Lastly, you need to look at the farmer needs and characteristics. So that's something that a crop consultant needs to look at. Is the farmer risk averse, or are they willing to take a risk and utilize a recommendation that may suggest that they don't need to spray? So you take all those host, pathogen and environmental factors, and the farmer needs and characteristics, you formulate that risk into an action plan, and that could be either spray, no spray, or reevaluate risk. So just very quickly, we're starting a new project across Canada, actually looking at trying to improve our management of Sclerotinia using fungicides and better risk assessment tools. So we're looking at things like seeding rate, a low seeding rate versus a high seeding rate, which may influence the extent that flowering occurs. We're looking at different fungicide applications and dual applications starting at the yellow bud stage, so actually a little bit before flowering. And at all of these sites across Canada, we're monitoring aerial spore load starting at about the rosette stage, both with the rotorod sampler, but we're also using the Spornado. At the same time, we're also monitoring rainfall and in-crop and ambient relative humidity and temperature. So we're trying to develop a better understanding of how all these factors that result in disease and factors that can be used to manage disease, how they interact to develop better tools to assess the risk of Sclerotinia. And with that, I'd be happy to try and answer any questions that any of the audience members may have.
Thank you so much, Kelly. That was terrific. Again, if you have a question for Kelly, please type it into the chat box now. We'll now have a short Q&A session. The first question, Kelly, is a little bit technical, so I'm going to do my best to read it out. I have to admit that I don't understand it nearly as well as you probably.
Sure.
I'll try my best. Have you ever done any research on seasonal ascospore release, SAR-on and SAR-end pattern maps or numbers in Western Canada?
SAR-N or SAR, I'm wondering if that's satellite technology perhaps. We've done some work with Heather McNairn out of Ottawa. They're using satellite technology to look at crop development, so when the crop comes into flower, and then also looking at satellite technology to assess things like soil moisture content. We've provided some ground assessments of Sclerotinia levels. In the past, we've looked at variation in the level of petal infestation over the growing season. So we can see quite dramatic shifts or changes in the level of petal infestation, which would reflect the level of spore dispersal and spore availability in the air. So we can have very low levels of spore production, i.e. petal infestation, as the crop is first coming into flower, but by the time it gets into full bloom, you can have very high levels of petal infestation, which would mean a very high level of spore load in the air. In that situation, it may mean that a full bloom application of fungicide is more effective at controlling that disease. So I hope that's addressed some of those questions.
Thanks, Kelly. Second question, how do these seeding rates translate into pounds per acre?
So the 60, that's a good question. So normally we seed on a seed per a seed per unit area basis, and I'd have to go back. So if you look at 100 plants per meter squared, it's roughly about 10 per square foot. So that would give you a bit of a rough idea. I'm not sure how that translates into pounds per acre, but if you're looking at about 100 plants per square meter, it roughly is equivalent to about 10 plants per square foot.
Kelly, is there any difference in the disease between sunflower and canola?
Yes and no. So you can still have aerial infection of Sclerotinia or of sunflower by Sclerotinia up onto the flowering portion of that sunflower plant, or perhaps the stalk. The other way that Sclerotinia infects sunflower is actually via germination of the sclerotia in the soil. And you don't get production of apothecia and ascospores, but you actually get what is referred to as myceliogenic germination of the sclerotia. So basically, the sclerotia become active, the fungus becomes active, and it produces hyphae, so those fine thread-like structures, and they'll grow from the sclerotia, and they'll grow into that sunflower root and up the root and into the base of the plant. So that's typically the two differences. In canola, typically most infections would result from ascospores that are released from apothecia that are on the soil surface.
Do low temperatures under 10, I'm assuming that's Celsius, do low temperatures under 10 have a bearing on Sclerotinia development?
Absolutely. So, like most diseases, they can develop over a fairly wide range. There's going to be temperatures that are ideal for the pathogens. But if you start getting to the extremes, so in the case of Sclerotinia, if you get daytime highs that are well above 30 degrees C, 35 degrees C, those are conditions typically that are not very conducive for infection and disease development. Conversely, if you start to get temperatures where your nighttime temperatures are well below 10 degrees C, so you're getting down to maybe 5 C or so on. We've done some work in the past with continuous temperatures of 10 degrees C, and you don't necessarily see a lot of germination of sclerotia. But you can have fairly cool conditions and infection occurring, so maybe above that 10 degrees C. It just takes the fungus a bit longer, so you need longer periods of leaf wetness or high relative humidity under cooler conditions in order for infection to occur.
How long can, in a no-till environment, how long can the spores stay in the soil and remain active and able to reinfect?
Okay, so the spores themselves, again, are fairly short-lived. Likely we're looking at the sclerotia themselves, and that's an interesting question that we've gotten over the last 20 to 25 years as we've moved to more of a direct seeding situation. And some of the research out of Brazil and I think out of the central Great Plains of the U.S. would suggest that direct seeding is actually quite a good strategy in terms of dealing with this. The sclerotia they like fairly consistent temperatures and moisture conditions, which you would tend to find more in the soil. At the soil surface or in that trash layer, you're going to have lots of wetting and drying of sclerotia, quite significant temperature changes over the course of the growing season and during the fall, winter, and spring. And those types of variations are not conducive to survival of the sclerotial body. So some of the work has suggested that conservation tillage or direct seeding actually might be beneficial in terms of reducing the viability of sclerotia.
Well, thank you so much, Kelly. That was terrific. I'd like to move on to our second speaker now. Steve Larocque is owner and independent crop advisor for the Alberta-based Beyond Agronomy. He manages over 30,000 acres of cropland and publishes The Spark, a weekly e-newsletter that focuses on innovations and new ideas gleaned from around the world. He's also a first-generation grain farmer who farms north of Drumheller and one of the first to implement a full-controlled traffic farming and inter-row seeding system in Western Canada. Steve, the floor is yours.
Thanks, Mark. And thanks, Kelly. Appreciate that. So I was asked to, just to talk about the some of the ways we manage risk around Sclerotinia and Fusarium head blight. I do crop consulting basically in a triangle from Calgary down through Okotoks. If you want to go about 100 or 120 kilometers straight east of Calgary, and then up to Three Hills and Drumheller, that's kind of the area I work in. So it's a real interesting area to work because we go from high elevation, above 3,000, and then down to about 2,600 feet above sea level. And it's amazing to see the temperature differences, even daytime to nighttime. And that really impacts some of these diseases. So we'll start off. There we go. Start off, I want to talk about Sclerotinia first, because Sclerotinia, as an agronomist, is probably one of my biggest nemesis. It really is a difficult one to predict. I've done the petal testing, kind of mid-90s or late 90s. 7-day turnarounds weren't quite enough to get us there. And I appreciate some of the technology that's coming with the Spornado. Looking forward to hearing more about that. But Sclerotinia is a really difficult one to manage around. And some of the tools that I use, or some of the checklists I use, just to measure risk. And there's a lot of things that go into how we choose to spray or not spray. And I look at the high-risk environments. So typically manured ground, I find high fertility. Manured ground, I think the mushrooms, the spores, they really like manured ground. We tend to be high risk, even in average to even below average rainfall years, we'll find incidences of Sclerotinia. So that's number one, is manured ground. Crop density and lodging risk. And I don't know if I can emphasize this one enough. Let's say in vigor 5440, may it rest in peace. It really showed the value of something that stands erect, something that can stand up to high fertility and pushing plant densities and fertility. When you have a vertical target and you have those petals dropping and infecting the main stem, when you have something that sits erect, then those petals, although they do fall on the leaf axis, they do so a lot less than when you have varieties that fall over. So when they become horizontal, it seems that those petals seem to stick, and they just easier. They fall on the main stems, and they create a greater infection. So not only are you trapping more moisture underneath with a lodging crop, you're also creating more of a surface area for those petals to fall. So that lodging risk and the canopy density is such a big factor in Sclerotinia infection. Rainfall and temperature, the last few years, we've had 50 days without rain, and then as soon as we go to decide whether we're going to spray or not, it rains an inch. So then it just changes everything. So what was going to be an easy decision becomes a more difficult decision. So definitely rainfall, if we've had an inch or two in the 2 weeks prior to flowering, that creates definitely an added risk. Wet pants, when I walk through, if I'm walking through in the afternoons and I still have wet pants, that's definitely a key indicator as well, that humidity in the canopy is that high that it's taken a long time. So those spores are going to germinate. Those apothecia is going to germinate. So west versus east. Now, Kelly mentioned that temperature, which was a really interesting note, because Emil Delano and myself and a few colleagues were always talking about why the high production areas like Highway 2 corridor and further west, we can do 60, 70, 55 up to 70 bushel canola, yet rarely do we find Sclerotinia. So some of my highest production areas rarely get Sclerotinia. And those areas tend to drop below 10 degrees Celsius at night. So they could be 8, 10, even 11 hours below 10 degrees Celsius. So it really takes a long time for those spores to really release. So it extends the period. They really don't get mass infections like I do when I go east. So as soon as I go east and those overnight temperatures are 15 or even 16, both of us could get up to 30, 32 degrees during the day along the Highway 2 corridor. But at nighttime, pardon me, to the east, we'll find higher temperatures at night, the greatest incidences of Sclerotinia. Weather forecast, I mean, if you can find a good one, localized, please let me know. I haven't found one yet, but definitely we're always looking at the forecast on temperature, not necessarily rainfall, because I think they can get pretty close on temperatures. And that when we look into the high 30s, high 20s, we know our incidences are going to be decreased, so our risk is decreased. Assessment tools. Now there's a few out by each, excuse me, there's a few risk assessment tools that are out there. Alberta Ag puts out one, Saskatchewan, and this one's from Manitoba. It gives you some number of years since the last canola crop and the disease incidence and density. So you run through your checklist, and more often than not, it'll tell you likely beneficial to spray. It'll never say don't spray. It'll never say you must spray. It'll always be likely beneficial. It's kind of ambiguous and doesn't really help the decision all that much. But it is, once in a while, it's pretty good to go through. But so integrated pest management, some of the things we do, we're always looking at what sort of return we're going to get for the spraying dollars. I mean, these are big numbers, right? When you're growing 8,000, 3,000 acres of canola, it's easily $30,000, $60,000, $90,000, $100,000 decision. So we look at what are the chances and what type of incidences will we be looking at in order to justify a fungicide. So if you look at a 3-to-1 return, $25 an acre, it could be 18 for the fungicide and 9 for the app. I mean, or even if you're spraying yourself, the $25 to $30 range for an application, that's 3-to-1 return. That's $75 divided by 10.50 a bushel. Perhaps you're a better marketer than I, and at 11, but roughly about 7 bushels an acre is what you're looking for return. Now divided by a 50 bushel crop, you can do it by 60, what have you. That works out to divided by 50% infection. That works out to 28%. So you really need a 28% infection level in order to have a return on your investment. And it's not often we do get those 30 to 50. You can, but and they hurt, but it's not often that you get that level of infection. 30% of that crop is infected, and you would have achieved that 3-to-1 return. Now as you know, there's been varieties that come on stream, Proven and Pioneer specifically. I think Proven is kind of renting their Pioneer's genetics, but there's a number of varieties out there that are starting to get Sclerotinia tolerant. They're not resistant, they're definitely tolerant, and the varieties may or may not perform as well. So sometimes you'll take the risk with a variety that doesn't have Sclerotinia, but because it's higher yielding, and you'll just have to spray a fungicide, which is not always the right decision, but for some it is. But there are genetics out there that are helping us manage that Sclerotinia. So again, back to that preventing lodging, variety, fertility. I mean, managing those two. Sometimes you have winners and losers where you're pushing high fertility, and because your genetics are changing and new varieties are coming on stream so often, it seems that we're changing up varieties quite often, which doesn't give us enough history to understand, the lodging risk of these varieties. So that's a bit of a challenge these days with varieties flipping through. Whereas 5440 was around for 10 years, you kind of knew how it stood. Even the 7444 on DeKalb. So you just get kind of used to some of the varieties that can perform well under high fertility. Fungicides, if we're going to go in, we got to go in early. Those early infections are the worst because they do take out the mayhem. So with some of the later infections, and oftentimes I do see planes flying around and the field is in full bloom. It's 50, 60% bloom, and it's not necessarily a waste of money, but in my mind, it's a high risk scenario. You really miss the window on being able to manage the disease that's really going to nab you, which is the 20 to 30% infection. So sometimes if we've got scale, if we've got 1,000, 2,000, 3,000 acres of canola to manage, oftentimes we'll do as much as we can with a high clearance sprayer and just have the aerial sprayer on standby to clean up some 500 or 1,000 or 1,500 acres, just so we can get in everything early and on time. Fusarium head blight, I'm really thankful we're in an area that doesn't really, we don't have a huge risk with Fusarium head blight. I don't think had any crops downgraded in my area or with my client base to Fusium. It's stuff on the seed, so more seed-borne, but not necessarily the Germinated. So some of the ways we do assess risk is we look at rotation, we look at residue. I mean, it does hang out on the residue. So oftentimes we are in a rotation. We've got wheat, barley, canola, peas. It's actually pretty rare that we're growing wheat on wheat, and even wheat inside of 3 years. So, pardon me, every 2 years. So we're usually a 1 in 3 on our wheat. So we do reduce that the knock-in level if it's around, and we grow hard red spring varieties. We grow some durum wheat and some winter wheat, and definitely the durum wheat is a little more susceptible, it seems. But really, we're pretty thankful for where we're living on the amount of risk that we have here. Risk maps there are. So 2020 puts out a pretty cool. It's more of a seed-borne map just to show you which areas are showing Germinated species, like it is. I don't think I have it included here, but yeah, there are some risk maps through each province that just show you the risk forecasts. And again, I mean, they're pretty general. So it really is, because we live in a climate with a lot of rain showers now. It just seems like one area or 2 miles away is a totally different risk area. So they're not broad. They need to be taken with a grain of salt with risk, but definitely something that we keep an eye on. Now the varieties out there, I didn't know this until I started looking up on the winter wheat. We don't grow a lot of winter wheat. We haven't had the opportunity, especially this year with the fall we had, to grow any newer winter wheats. But Emerson is now the first resistant I see winter wheat to Fusarium, and these are all charts we run through. And if you look at some of the most common varieties that we grow for hard red, we got Redwater and we've got CDC Go is a very popular one. They're all MS. They're moderately susceptible. So they're not intermediate. They're not MR. They're actually moderately susceptible. So much more. And Stettler is another. Those are popular ones. So we look to varieties probably second, but we do keep an eye on which ones are coming down the pipe and with Fusarium resistance. Integrated pest management. On the timing side, a big part of that is fertility. A big part of that is seeding depth uniformity and the way we manage our residue. I don't have any photos. I tried to find a few photos of wheat growing on canola residue, because that's typically what happens. It's a canola, wheat, barley. So if that wheat's on canola stubble, that canola residue really wreaks havoc on emergence, and residue spread as well. You just have so many uneven residue spreads out there that your emergence rates are so much different and so variable across the field that if we did into incidences where Fusarium started to creep in a little bit more, we'd be in a lot of trouble. The timing of Fusarium fungicide applications is really specific, as you know. I'll talk about it in a second. But residue management is key, and being able to get that crop up and even and uniform. And we can do that through better residue management. I mean, we can drag heavy harrows around. We can manage, barley straw and wheat straw. Okay, pea stubble, you're not heavy harrowing, but we can manage that. But canola residue is really hard to drag around with a heavy harrow. It's you're trying to drag feathers around. So that's where I see the biggest risk is in uneven emergence, and that's delaying maturity. That's delaying tillering. In fact, when you have variable plant stands, that creates higher tillering rates in some areas compared to others. So then you get certain areas of the field that are delayed and really are time when it comes to fungicide. Tom Wolf's done quite a few, let's say videos. He's presented a lot on fungicide timing and even nozzles, front to back nozzles. I mean, they are better. And he had said if you're going to use a regular air induction, flat fan or air induction, speed's actually okay when you're, within reason, but when you're hitting a vertical target, speeds a little bit faster is okay when you're applying fungicides. Whereas leaf diseases, you're actually wanting to slow down. So fungicide timing, this is where it gets difficult. It is, 3 to 5 days. When you're looking at that crop and the heads are 75% emerged or 50 to 75, you got 3 to 5 days between 75% heads emerged to 50% flower. So, I mean, we're in July. I mean, we've got 16, 18 hours of daylight. It's hot. You know, things are firing really fast. So being able to get in there and across those fields before that 50% flower is really difficult. And even more so if you've got an ununiform stand. So as soon as you see those awns start to pop up, you know, it's roughly 7 to 8 days to 50% flower. So you basically got less than a week to get across to your fields. And we're actually starting to almost get into the practice of trying to stage Fusarium timing, even though it's not as great a risk in our area. We know that it's creeping up, and we know that it may be one day that we are spraying for it on a consistent basis. So we really have to gear up to figure out how we cover this ground, you know, in less than 7 days. So it's one of the things we're definitely looking at. The elephant in the room is that, you know, in other areas of the provinces, yeah, we're relying on triazoles. Triazoles, you know, Prozero's okay. Diaconazoles and tibuconazoles are okay. Metconazole, you know, they're all triazoles, and that's all we're using right now to manage this disease. So I just wanted to point that out, that it's not, yeah, it's really difficult. I know there's SDHIs coming in, but newer fungicide groups, but we really need to focus on managing it differently and not just fungicides. And if we're going to use just fungicides, we have to find alternatives to triazoles, or we're going to be in the same shape as the Europeans with resistance. So Sclerotinia and Fusarium head blight, it's one of those things. I mean, what I tend to do, and it's just my perception, or just the way I manage risk, is I always like to hedge. You know, when it's a really difficult decision, and again, it's, you know, $30,000, $60,000, $90,000 decision, $100,000 decisions, we always hedge, because we don't know what's coming ahead, but we know what's in front of us right now, and we'll say, you know what, we may not have all the information right now. If we spray 75% or choose the fields that look the best or have the best potential, that's the way we manage our risk. You know, we may not spray every field. We'll spray a certain percentage, maybe 2/3, maybe half, whatever it is. But sometimes we won't spray everything. And it's a decision every year. It's not a no-brainer. We make those decisions every year. We don't just go out and do it. So there you have it. That's my take on managing risk and some of the management tools we use to assess risk and manage those diseases, both Fusarium and Sclerotinia. So if you have any questions, by all means. Thank you so much.
Yeah, if you have any questions, please type them into the chat box now. We'll now have a short Q&A session again before we get to our third and final speaker of the day. Steve, in regards to Sclerotinia fungicide timing, what is more important, getting coverage on stems and leaves or getting coverage on flowers and petals?
Flowers and petals. You really want to coat the flowers and petals because those are the sources of infection. So you coat those, and they then fall on the leaf axis, which is where the infection point occurs. So yeah, in a nutshell, you want to hit the petals and flowers.
Can you give us another quick recap, Steve, on what role new varieties play in battling Sclerotinia?
Sure. Yeah, you know, with the genetics that have come on stream in the last even 5 years with the S varieties, the Sclerotinia tolerant varieties, they're definitely another toolbox. They're definitely another option. They've been slow to come on the Liberty side, on the Liberty Link side, but definitely, you know, a little faster on the Roundup Ready. So for a lot of Liberty growers, they're kind of, you know, they're looking at when those genetics come in. But on the Roundup Ready side, yeah, the Pioneers and the Provens, they've come along and given us another tool. And again, they're not a perfect one. It's not like you have resistance. So, but if you have, you know, heavily manured fields where you have high risk areas where you've had it in the past and serious infections in the past, like 50, 60%, some of these tools are really, really helpful, and they'll reduce the fungicide, right? So that's another thing to consider as well. So we're not totally relying on fungicides all the time.
Steve, do any fertilizers help reduce FHB?
Do any fertilizers? I couldn't answer that. No, I wouldn't know if any fertilizers. Not that I'm aware of. the only aspect of fertility that I could comment on is, you know, seed placement and being able to have that starter fertilizer where we can pop it out of that plant out of the ground as fast and as uniform as possible, and that's usually P and K. Being able to start a place as much as we can with the seed that's as safe as possible. That's some of the ways we just manage the timing. But to change the infection or level of infection, I'm not aware of any fertility or fertilizer that would help us.
Well, thank you so much, Steve. We're going to move on to our third and final speaker of the day. Thanks again for spending your Friday afternoon with us. Trevor Blois is Disease Diagnostician Supervisor for 2020 Seed Labs. He's one of the most knowledgeable experts on seedborne diseases in Western Canada. His maps tracking Fusarium graminearum infections in Alberta are regularly used and referenced by many experts in government and industry. He's accredited for true loose smut analysis in barley, as well as pedigreed seed crop inspection for cereals, pulses, hybrid canola, and plots by the Canadian Food Inspection Agency. Trevor, the floor is yours.
All right, thank you, Mark. That was pretty good background information from both Kelly and Steve. So now I'm going to be talking about a specific tool that we're providing to farmers to give them the chance to strike back against those sinister pathogens that they were both talking about. So I'll start out talking about the Spornado. I'll talk about what is the Spornado, how it works. I'll be talking about what pathogens we test using the Spornado. And then I'll be talking about some specific results from some of the testing that we did during the 2018 growing season. The Spornado, it's a new tool that we're providing. So it's going to provide information to growers that they never had before and help make them make those difficult decisions that Steve was talking about when to spray, whether or not it's required, hopefully, by looking at those inoculum levels that are present in the field. So the Spornado is a passive spore catcher. Kelly went over the different types of spore catchers that you can have. So this one does require air movement to move the spores through the catcher. Unlike the Burkhardt or the Rotarod, which are actively sucking air through there or require electricity to run. This one does not require any electricity. It's self-contained, and it just sits out in the field and lets spores pass through it. So the test that we do use is a DNA test. Kelly mentioned the different ways we can test for pathogens, test for spores from spore catchers. So the DNA test is really useful because it is very sensitive, and we can pick up low levels of spores out there. It was designed out in Ontario. They made it with the intention of picking up late blight spores in potato fields, and it was really successful out there. So bringing it out to Western Canada, we were looking at what sort of different pathogens we could test for out here, and having both fields of cereals and canola in the same rotations, it made a lot of sense to focus on Fusarium graminearum and Sclerotinia because both of those are airborne, and quite often you have a canola field right beside a cereal field. The spores are collected on a membrane inside the Spornado, and it's easy to change. It just pops out. We have this mobile tracking system. You can see some photos in the bottom right corner there showing what it looks like on your phone. You can just take a picture of the barcode that's on the Spornado cassette, and that will tie it in and associate the testing with that specific cassette. And then you can see all the information that it pulls right from your phone. There's the GPS coordinates, so you know exactly where it came from. what the current weather conditions are as well. So that can be really useful in keeping track of when you both put in the cassette and remove the cassette. And then you can just ship the cassette to our lab in Nisku, or you can drop it off yourself, and we'll do the testing at the lab. So the testing is a qPCR test. We are looking at both Fusarium graminearum and Sclerotinia on every cassette that we test. So with that test, the big benefit is that it's really fast. So you get the turnaround time of about a day if it's submitted to the lab before 2 p.m. But if you get it to the lab in the morning, we can get it done regularly in that same day. So that's really important for getting that fast information on whether or not you need to spray to help control these diseases. The results that you get are positive or negative. So as Kelly mentioned, with the different types of testing, this one is not quantitative. So we can't know how much was moving through there at the time, but we can tell you whether or not it was present in the area during that collection time period. And with qPCR, we look at the LOD, which is the limit of detection, and we determine whether or not it's positive based on that. So at the limit of detection is where 95% of the PCR replicates will amplify. If it doesn't reach that, then it's no target pathogen detected. Sometimes we get trace amounts where we see amplification of the DNA, but it doesn't quite reach that level and it's not replicable, so we call those trace. And then positive is where it gets to or above that limit of detection. And sometimes we do see cassettes coming through that have very high levels of DNA, and then we make a comment in those cases. This is the information sheet that goes out with every Spornado that was deployed this year. So it has a lot of simple information on how to assemble it. Pretty much you just put it onto a pipe and stick it in the ground. And we recommend putting it so that it's about 1 foot above the plant canopy. So you might have to change the height as the crop grows through the growing season. We recommend putting it at least 25 meters into the crop, having it downwind from the prevailing winds. But if you know that there's going to be inoculum likely coming from a field that had a lot of Sclerotinia in it last year, for instance, then you would want to put it near that field edge. And then we just ask, there's some instructions there on the right side you can see about how to remove the cassette and ship it into the lab. And then we have some recommendations about when to start putting the Spornado out into the field. So you'll want it in there before the time you're before flowering, so that you can get a sense of whether or not inoculum is present and whether it's building. And then during that flowering period, you'll want to increase the amount of testing that you're doing just to get better resolution. With everything, of course, we're looking at the disease triangle always. And so a big part of everything is the environment, and both Kelly and Steve talked a bit about this. On the left, you see we have this great map from Alberta Agriculture now that assesses fusarium risk across all of Alberta from all of their weather stations. So a lot of that's based on the precipitation in those areas. And so that'll give you a good idea if it's a risk for disease to come up if you have inoculum in the area, but it doesn't tell you if you have inoculum in the area, of course. So in a lot of areas you might be seeing, oh, I have really high fusarium risk, but in reality, because there is no Fusarium graminearum present, your risk will be much lower. On the right is that Sclerotinia stem rot checklist that Steve was mentioning. And you can see they do have a part for the weather forecast, but then also the regional risk for apothecia development down there. They just say none, low numbers, and high numbers. So it's not very specific, and the Spornado should be able to give you a lot more specific information. So the Spornado really looks at the pathogen part of the disease triangle and focuses down on that. So here's a specific example from 2018 during the growing season where a grower in the Viking area had 4 Spornados in a relatively small area. And it was quite close to the weather station. You can see it down on the bottom of that map there. So field 1 was to the southeast. Field 2 was to the northeast of that. Field 3 was to the northwest, and field 4 was to the southwest. So from the weather data, you can see that there was elevated fusarium risk for the time period that the Spornados were deployed. He had them out there from July 12th until July 17th and changed them every 48 hours. So you'll see the results in that bottom chart there. The precipitation is in the blue bars. And you can see that the risk in the map or in the chart above it is really driven quite a lot by that precipitation. So more precipitation certainly drives the increase in the risk. And there was a little peak there as well around July 14th, where we saw it go up into the severe fusarium risk area. So as far as the results go on the cassettes that we were testing, we see the lines in the bottom chart there. 1 is where we were picking up trace levels of Fusarium graminearum, and the 2 is where we were picking up levels at the limit of detection. So at July 14th here, we started to get trace levels showing up in the most southeast field there, field number 1. And then 2 days later, July 16th here, it went up to the level where it was at the limit of detection, where it's where we consider it positive. Likewise, field number 4 down here in the south as well, we were picking up positive levels. Field number 3, at that same time period, we were getting trace. Field number 2, we didn't pick up anything at all. So it really shows, even on this small area, that there was differences in fusarium. And if you just use that weather station data for your to make your assessment, it's not as local as the Spornado can be. The Spornado is hyper local in a way. So that's from 2018. For 2019, we are looking at a wider distribution. We had quite a few in Alberta, Saskatchewan, and Manitoba last year. Unfortunately, there was lower levels of disease, so we didn't get as many positives as we had hoped. But as it goes on, we're hoping for a wider distribution. We're looking at a surveillance network. So having these interspersed throughout the provinces, you can get a sense of risk and be able to track the pathogen a lot easier during the growing season. We're looking at additional pathogens. One that Kelly mentioned was stripe rust. And that one can travel long distances as well, as he said. So a surveillance network could give you early warning if it's moving into your area. So contact the lab to get yours now. And with that, I'll take any questions.
Thank you so much, Trevor. That was terrific. A question you probably get a lot, I'm sure, when you talk about technologies like this, are what are any potential costs associated with using it? Can you give us a little synopsis of that?
Sure, yeah. So we are looking at changing the costing package for it. But I can say last year for the testing, it was $200 for each cassette that we tested. And that got you results for both Fusarium graminearum and Sclerotinia. So, it's pretty good if you consider how much is riding on a fungicide's application, as Steve was talking about.
When should people, and this was a topic addressed a little bit earlier as well, can you give us a refresher on when people should start trapping spores?
Yeah, so like I said, you'd want it out there with both Fusarium graminearum and Sclerotinia. Fortunately, it's fairly close when you'll see those infections occurring. Right, it's for flowering for both of those. So you'll want to have them out earlier before that period. So perhaps late June. To get a sense of if there is inoculum in the area. You could test every week at that point. And then during the say flowering period anthesis for cereals, you might want to tighten it up to every couple of days, as that grower from the Viking area did, every 48 hours. And then you will have an idea if levels increase quite quickly, because the resolution is only as good as how often you test it as well. So when at those pivotal periods where you really want to know when to spray, it's important to test often.
Thank you so much, Trevor. That is all the time we have for today. I would like to thank our sponsor again, 2020 Seed Labs, for its support. Again, a pesticide applicator credit applies to anyone in Alberta who viewed this webinar and has a pesticide applicator license. Simply go to germination.ca/applicator-form, fill out the form, and email your completed form to Kevin Zaechuk. His email is kevin@2020seedlabs.ca. Again, this webinar was recorded and will be made available at germination.ca. Again, thank you so much for spending your Friday afternoon with us. I'd also quickly like to thank our technical assistants, Teresa Kurdziewicz and Kyle Dradawani, who've been working behind the scenes to make this a very successful webinar. Thanks again, and we hope you have a terrific day. This is Mark Zinkowitz of Germination signing off.